Welcome to Physics. We're studying Chapter 6.3, Elastic and Inelastic Collisions. Quick reminder, the review days are February 3rd and 4th, and the unit tests will be on the 5th and 6th. We're going to cover elastic and inelastic collisions, and then after you're done with the quick notes in the beginning of the period, we'll go over and do the practice problems E, F, and G. And I'll remind you about the egg drop project. Homework is very simple. You're going to work on the egg drop project and review for the next week's tests. The learning targets for Chapter 6.3 are: I can identify different types of collisions. I can determine the changes in kinetic energy during perfectly inelastic collisions. I can compare the law of conservation of kinetic energy in perfectly inelastic and elastic collisions. And finally, I can find the final velocity of an object in a perfectly inelastic and elastic collision. In perfectly inelastic collisions, when two objects collide and they move together, they do not separate. The equation is mass 1 times velocity 1 plus mass 2 times velocity 2 initially, and then you add the two masses and you get a final velocity. Kinetic energy is not constant in inelastic collisions. It is converted to sound and internal energy as the object deforms. Increase in kinetic energy can be calculated by using 1/2 mv squared. And I've included also a magic triangle. Elastic collisions, the two objects remain separate. They remain the same shape after collisions, and both momentum and kinetic energy are the same. Most collisions are neither elastic nor perfectly inelastic. Most objects in elastic collisions do not stick, and in near elastic collisions, objects lose energy to internal energy and sound. Kinetic energy is conserved in elastic collisions. If purely elastic, both momentum and kinetic remain constant before, during, and after the collision. There are again three types of collisions. There's a perfectly inelastic, elastic, and inelastic. The two objects stick together after the collision so that the final velocities are the same for a perfectly inelastic. The two objects bounce after the collision, so they move separately in an elastic. And finally, the two objects deform during the collision so that the total kinetic energy decreases, but the objects move separately after the collision for an inelastic collision. The conserved quantities for perfectly inelastic are momentum. For elastic, both momentum and kinetic energy. And inelastic, only momentum. We'll be working on practice problems 6E, 6F, and 6G. Finally, work on the egg drop project and review for next week's test.